Digital Principles and System Design. So review of Boolean Algebra, and this is vanilla. So we are going to have a review of Boolean Algebra. So Boolean Algebra is a mathematical system that is defined with a set of elements, that is your Boolean variable and its operation and a number of postulates. So finding a simpler and cheaper but equivalent realization of a circuit is important to reduce the overall cost of design. So if your equation is going to have some 5 terms, and if I'm able to get the same output with the help of 2 terms, so what happens, that 3 terms has been reduced, so which reduce the overall cost of the design here. So this can be obtained using the Boolean postulates and theorem of the Boolean algebra. So we'll see the Boolean postulates and Boolean algebra and theorems of the Boolean algebra. The postulates that we are going to see is closure property, identity property, commutative property, distributive property, and inverse. So here we'll be seeing it for both your addition as well as your multiplication, the duality of it. So for closure property, the results of each operation will be either in 0 or 1. So next is identity property. So 0 is the identity element of the addition. So a plus 0 equal to 0 plus a equal to a. And then for multiplication, 1 is the identity element. So a into 1 equal to 1 into a equal to a. Next is the commutative property. A plus b equal to b plus a. And a into b equal to b into a. So next is distributive property. So a into b plus c is equal to a into b plus a into c. Similarly, a plus b into c is a plus b into a plus c. Inverse is a plus a inverse equal to 1, that is identity element. So a into a inverse equal to 0, that is the identity element of your multiplication. So now next we will see the Boolean theorems. So if you are going to add any Boolean variable with 1, the value is going to be 1. Similarly, if you are going to multiply any variable, Boolean variable with identity element 0, the value is 0. Independent. So this is a plus a is equal to a, and a into a is also equal to a. Involution is inverse of inverse is going to be the original value. Absorption. So a plus a into b equal to a, and similarly a into a plus b equal to a. Associative law, a plus b plus c equal to a plus b plus c. So a into b into c equal to a into b into c. So De Morgan's theorem is a plus b whole bar equal to a bar into b bar. Similarly, a into b whole bar equal to a bar plus b bar. Next is consensus theorem, ab plus a bar c plus bc. Here this a and a bar, original and then the complement of it. If you remove this one, the remaining literal is b and c. If this forms a separate term, you can remove this term. So this is ab plus a bar c. We will consider this bc as a redundant term. So similarly, a plus b into a bar plus c. So this a and a bar you have. So remaining term b plus c is there. It's considered as a redundant term. So here quite common, we will be using this De Morgan's consensus theorem. We'll see the logic gates which is useful for this Boolean algebra. So logic gate is R, the symbol is this one. So you can write the expression here. This A and B is said to be input, Y is said to be an output. You have this 3 is said to be a Boolean variable. What is the difference between variable and Boolean variable is variable can have any number as a value, but Boolean variable can have either 1 or 0. So the expression is A plus B. So in your Boolean expression, wherever you have this plus, we will be using this OR gate. So the truth table is AB is an input. So if it is a capital, you have to use a capital. Whatever the variable you use here, that should be used in the truth table too, and in the expression too. So AB, so 2 variable is there. So if n number of variables you have, the number of different combinations you can get is 2 power n. So 2 variable input variable 2 power 2 is going to be 4. So 0, 1, 2 and 3, that is 0, 0, 0, 1, 1, 0, 1, 1. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1, 1, 1 plus 1 is 1. So how can I say it in the statement? If any one of my input is 1, output is 1. The next gate is going to be the AND gate. So the symbol of AND gate is this one. A and B is a input Boolean variable, Y is output Boolean variable. So expression is y is equal to a into b, and here this is the truth table. So a into b, so 0 0 0 0 1 is 0, 1 0 is 0, 1 into 1 is 1. So I can say it in words as, if all the inputs are 1, my output is 1, else it is going to be 0. Next is NOT gate. So symbol of the NOT gate is this, and the expression is, it's a single input gate here. So whatever you are going to input, give the input, that will be the complement of it. So if I give 1, the complement is 0. If I give 0, the complement is 1. The next gate is exclusive OR gate. So exclusive OR gate symbol is this one. So XOR, in front of XOR you have this one. So expression is y is equal to a, this is exclusive, plus circle. So exclusive OR of b, and here if both my inputs are different, then the output is going to be 1. If both the inputs are same, the output is 0. It's in other words. Next is your NAND gate. So NAND is nothing but n. I can write this as n plus AND. So NOT gate, combination of your NOT gate and AND gate is nothing but your NAND gate. So this NOT gate is given by this bubble, and then this AND gate. So I can give that in the expression as y is equal to ab bar, and then I can write the truth table. 0 0 0 bar is 1. If both my input is 1, output is 0. For all other things, the output is 1. Next is your NOR. NOR is nothing but the combination of your NOT gate and then your OR gate. So here I hope you can guess your symbol. So this is your NOT as well as your OR. So y is equal to a plus b whole bar, and then 0 0 0 bar is 1. So I can say that if both my input are 0, output is 1. For all other inputs, the output is 0. And here we can see how to simplify the number of literals or the terms, so that you can reduce the cost of your device here. So here simplify a plus ab bar plus a bar b. So here I can take this in these two terms. But you have to see the expression, find the possibilities of it. Here in these two, my a is common, so I can take it out. 1 plus b bar plus a bar b. So 1 plus b bar is going to be 1. So a is a into 1 plus a bar b. Now in this one I can use your distributive law. So what's the distributive law? A plus a bar into a plus b. So this is the distributive law. So here a plus a bar, by inverse property, a plus a bar is equal to 1. So here a plus b. So totally I have how many literals? 3 terms. Literals 1, 2, 3, 4, 5 different literals. So it has been reduced to 2 terms with 2 literals. So here a simplify a b bar plus c plus d bar whole bar. So here this whole bar you have, I can use your De Morgan's theorem. What is this De Morgan's theorem says? A plus b whole bar equal to a bar plus b bar. A plus b whole bar is equal to a bar into b bar. So here this a b bar whole bar into c plus d bar whole bar. So I can write this one. Again, I can use your De Morgan's theorem. So what is this De Morgan's theorem? States that AB whole bar is equal to A bar plus B bar. So here this AB bar whole bar I can write as A bar plus B bar, A bar plus B bar whole bar. So it becomes B into C plus D whole bar is equal to C bar into this D. So D bar whole bar is going to be D again. So your letters is going to be A bar plus B into C bar D. So prove that. Here they may ask you to simplify, or they may ask you to prove. Here they have given this problem to prove. So here how many terms you have? 1, 2, 3, 4, 5, 6 terms here. That is reduced into 2 terms, and the literals also has been reduced. So now we can see how to do this one. So LHS equal to this one. In this one you just see the first 2 terms your x is common, so I can take my x commonly out. And here in this term your x bar is common, so I can take this x bar out. In this one your x is common, so I can take x out. So if it's so, I can have this as x 1 plus y bar y z. Here y is I can take your sorry, x bar y itself, it's a common. So now z plus 1 plus here if I take x y w plus w bar. So you know the theorem 1 plus, if you are going to add anything to your identity element, the value is going to be 1. And this is inverse property, w plus w bar is going to be 1 again. So I can write this as x plus x bar y plus x. So now this x plus x is an independent property. So it becomes x plus x bar y. Now I can go for the distributive law, x plus x bar into x plus y. So in this x plus x bar, because of your inverse property, this x plus x bar is going to be 1 here. So the remaining value is going to be x plus y. So thus that is proved to the RHS. So now I will give the problems for practice here. So whatever, so simplify to the minimum number of literals. So whatever literals here they have used, it is each and every variable is said to be the literal. So small x na should be small x, capital X na should be capital X. Small b na, a b na, you should have small a b. If it is capital A b na, you have to use your capital A b. So here I have given the problems. For simplification, I have to given two problems. For proof, I have given two problems. Thank you guys. Have a nice day. Subscribe my channel for automatic updates.